Hi everybody, in this video we're going to be working with the change of base formula, and this is really a nice formula because it means from now on you can stop thinking so much about say for instance when I say log base 5 of 125, I'm really asking you, do you know what power I have to raise 5 to in order to get 125? And if you're really good at math, maybe you recognize that that's 3 because it's 5 cubed, because 5 cubed is 125, okay? But if you really don't know, or if we get something like these examples, like 2 raised to what power gives me 30? Well, 2 doesn't, I can go 2 times, like 2 is 4, then it'd be 8, and then it'd be 16, then it'd be 32. So 2 doesn't go into 32 power-wise evenly, right? It'd be like an odd number. The change of base formula is the way that we're going to be able to solve for values like this that are decimals, and we're going to be able to do it quickly and easily. And in fact, it'll work even for the easy examples like this, where we'll get the 3 out of it. So this is an important one to know. And the idea is this. Ready? If I have a logarithm, some number for a base, some number here, I can split it up into 2 separate logarithms. And I can just use, and you will never use this, ready? In fact, let's just look at this one. Forget this formula here exists, ready? It means that I can write log of the big number divided by log of the small number. And the log button that we see here is the log button on our calculator. Okay, notice it's not written, so it's base 10. So in other words, I can take this logarithm here and I can write it as log of big number over the log of the base. If I type that in my calculator, I'm going to find out exactly what I have to raise it to. Now keep in mind, 2 raised to the, fifth power, right? 2 raised to the 5th power is 32. And 2 raised to the 4th power is 16. So I bet 2 raised to something like 4 point something will give me 30. Somewhere in between there, right? It's got to be between 4 and 5. Let's find out. Ready? Log button. Let me move it up so you can see. Okay. The log button right here of 30. And this is the only thing it's going to catch. Ready? In the logarithm. Divided by log of 2. And in the logarithm, parentheses are extremely important here, and it gives me an answer of 4.9. Wow, look at that. Exactly what we thought, right? 2 to the 5th power is too big. 2 to the 4th power is too small. It's got to be somewhere between there. It's 2 to the 4.90689 power. So let's go ahead and just say that we're going to round to 2 decimals, okay? And so because it's 4.906, it looks like I need to round that 0 up to a 1. It's about, squiggly parenthesis, or equal sign, it's about 4.91. Log base 2 of 30 is about 4.91. And all that says is if I raised 2 to the power of that previous answer, 2 to the 4.90689, so on and so forth, I would get exactly 30 out. That's all it means. Okay? The nice thing is, you'll see in this notes, ready? I can use the log button or I can use the natural log button, and it doesn't matter. If I would have gone and I would have done natural log of 30 over natural log of 2, I'm going to get the same thing out. So on my calculator, just to prove it real quick, parentheses are deadly important. Ready? Log of 30, in parentheses, log of 2, and I get 4.906. So in other words, choose which button you want to use. Doesn't matter. Okay? So let's evaluate just a couple of more. Log base 5 of 4, I can rewrite as log 4 over log 5. The base goes on the bottom, right? Base of the logarithm on the bottom. They both start with B, so use that to remember, okay? If I do on my calculator, log of 4 in the parenthesis divided by log of 5 in the parenthesis, I get 0.861. Because that's a 1 there, I can keep this as a 6, right? I don't have to round up. So it's about 0.86. Notice that I could have also done, one more time to prove it, log base 4, or natural log of 4 divided by natural log of 5, ending the parentheses both times, and I once again get 0.86, right? Okay, last one then, probably know what we're doing here. Log of 100 over log of 3. Base on bottom. Natural log of 100 divided by the natural log of 3. Whoops. Hit a button there. Natural log of 3 Okay, make sure to end the parentheses both times, and I get an answer of 4.191, so I can keep it as 4.19. It's about 4.19. In other words, 3 raised to the 4.19 power would give me 100. We can check it out pretty easily. 3 raised to the 4.1918 power, it's 100, right? I just had to round it. So hopefully that makes sense. That's the change in base formula. That's going to be huge for us. That means we can start solving for x with more complicated equations. That's enough for today. That's a lot of homework to work on. Plenty of examples hopefully to follow. Sorry if I got a little long-winded in the videos. I just wanted to make sure you had a lot of examples to see so you could kind of see the patterns that start to develop. All right, there we go. Let's work on homework.